Welcome to the Wave Spectral Fatigue Analysis course. And to begin, we're gonna copy these 5 files from the dynamic analysis folder. Okay, after that we can start by editing the C-state input file. So double click on it. Here we're gonna include the loads for the transfer function generation. Go to insert input line. Let's sort that and look for load CN. The first one, this one. Okay, and right here you're gonna insert another line. It's called transfer function generation, and the type we're gonna use this one, the default one, AL, and the number of waves gonna use 6, wave stepness 0.05, beginning period 10.0, period step size 1.0, and the number of crest positions per wave 18, and the wave direction 0.0. Include buoyancy below midline, no, and this one can use the default. Okay, let's insert another input line. You're gonna use default, and the number of waves this time is going to be 6 again, and the stepness 0.05, beginning period 4 point, and finally the end line. So now we can save this file. Let's change the name to fatigue so we can identify that. Okay, here is our C-state input file is done. Let's go. The another step is to create the wave response input file. Go to DataGen, create new data file, and then OK. Here we're gonna choose dynamic and then wave response input file, and then OK. The first line we're gonna input is the wave response options. The units gonna change to English. Okay, gonna use all time points and generate plots. Yes, and right here the equivalent static options change to equivalent static loads, and the maximum allowable iterations gonna use 10. Okay, so that's it for this line. I'm gonna deal with the plots. Insert input line and transfer and response function plot. I'm gonna change the overturn moment plot data save to plots only. The base shear also plots only. The independent variable, let's choose both. Okay, and plot symbols, yes. And the next line is the damping line. Let's search for the damp command, we're gonna use a constant modal damping. So choose this one here, and then OK. And we're gonna use 2%, right? OK. So it's finished. Gonna insert the end line and save the file. The name of the file is wvremp.dat. Can close now. Here it is, our file. And the next step is to create the wave response run file. So go to analysis generator and pick up dynamic, then determinist wave transfer function generation. And the SACS model file is your file that you get from the dynamic analysis. It's gonna ask for the C-state input file, this one that we've just created. Here it is, and the wave response input file. And the mode shapes and the mass file from the dynamic analysis. These files we've copied from the dynamic analysis folder, okay? And right here, you're gonna insert file ID. You're gonna use TRNSFR and click on reset output ID, right? Change the name of the files so you can identify them easily. So here's our analysis. We just have to check these boxes. This one, just the solve one, and run the analysis. Okay. This box is telling you that you are going to need this license to run this analysis. So you can click OK if you agree. Let's search for errors in the list file. No errors. And here is the plot of our transfer function. Let's open up. And here it is. You can go back and change some definitions, but we're gonna consider that this is okay for now. And the next step is to create our fatigue input file. Let's go back to the files folder and open up DataGen, create new data file, and then OK. Go to post-processing, fatigue input file, then OK. And the first line we're gonna insert is the fatigue options. Okay. Fatigue options. And let's change some definitions here. And the design life, we're gonna use 20. The life safety factor 2. The report option, I'm gonna use full. And use load case dependent SCF, change to yes. And the SN curve, we're gonna use WJT, welded joint with no weld improvement, and the SCF option, we're gonna use Timu formulation. Okay. And that's okay. Let's insert another input line. It's the fatigue option 2. This one is to change some additional report options for inline tubular connections. Okay, click OK right here, and in the member detail report PT and member summary report in joint order, yes, and another summary report with the life order, yes. SCF validity ring check, and yes. Inline tubular SCF, we're gonna use American Welding Society. Tubular inline check, we're gonna use yes. And the effective thickness for grout, we're gonna use this one, use the default. Okay, you can jump to the next line. We can select some joints for reporting and remove some others. So go to joint selection. Right here. And now we want to remove some joints, okay? So we're gonna change to yes, and right here we're gonna type the joints we want to remove. 501, 3, 5, 7, 801, 3, 5, and 7 again. Then apply, and we can override some fatigue options for specific joints. You can do it by inserting the joint override line. Here we're gonna type the joint name and the SN data option. We're gonna use the API X curve, just that. And the next line, we're gonna remove some groups. We can remove either by joint or using groups. Go to insert input line and look for group selection. Right here, you're gonna change to yes to exclude the groups and type the name of the groups. Okay, and the groups are PL1, PL2, PL3, PL4, W.B are the piles and the wishbones. We can also override the SCF for some particular joints, and can insert input line with this stress concentration factor selection. And for the X joint, you're gonna use the Marshall formulation. we have an option to calculate the stress concentration factors at the chord face. We just have to enter the command relieve, and there are two ways of telling the programs the waves we're gonna use for the transfer functions, and you can do it manually, or you can tell SACS to look up the waves in the C-state input file using the SACS line. So go to insert input line again and search for the SACS line. Then okay, now you're gonna input the fatigue cases. Go to insert input line. There are different fatigue cases. Right here we are using the spectral wave fatigue case, so choose this one, and the fatigue environment number, this one is the first. I'm gonna use 1, and the fraction of design life 0.47, and the wave direction is 0. The next step is to input the wave spectrum for fatigue analysis. This can automatically be calculated using wave frequency data. The initial information for the scatter diagram is input on the SCATT line. So let's search for this. Here it is. We're gonna use the period type dominant or peak, period factor 1, wave height factor 1, and the wave spectrum type Pearson-Moscovitz spectrum. And now we're gonna enter the scatter diagram wave height information. So go to scatter diagram wave height, and the first wave height is 1, the second one is 3, and the third one is 6. Then apply. Next, I'm gonna enter the scatter diagram frequency of occurrence line. Period is 1.5. The frequency is of occurrence is for the first wave period 15, 0.1, 0.1 again. Sorry, it was 1, not 1.5. Now I'm gonna insert another line for a different period. And I use 3.0, frequency 0.1, 0.19, and 0.11. Another one. We can either type the line, and now it's 5.0, 0.05, 0.08, 0.05. Here we go another line or 8 seconds, and 0.02, 0.03, 0.02, and that's fine. Let's go for the second fatigue case, 0.02. After the analysis, we want to see the results graphically, so some joints has to be extracted. You can do it automatically using SACS with the command line extract. Okay. And in the automatic extraction, let's change to yes, all. So it's finished. Let's input the end line and save our file. The name of the file is fdgemp.dat. Here it is. So let's run the analysis. Go to analysis generator, reset the analysis type, and the file ID, we're gonna use fatigue, and the type of analysis is post-processing, and the subtype is spectral fatigue. Okay. And here we're gonna pick up the fatigue input file, the first common solution file that was generated at the first analysis with the transfer function generation, the wave response analysis. The first C-state input file with the waves. Here it is. And now we can run the analysis. Clicking. No errors found. Let's go to the results. Scroll down until you find the member fatigue report in the damage order. Or you can just search for damage order. Here is your report, so you can check for the results right here. Okay. There's another one in the joint order. Here are the results with the damage order, and you can check your results with the manual provided. Okay, and now it's time to check the results graphically. Go to the post-view database that we got from the dynamic analysis. Open up, go to joint, import fatigue, and I'm gonna use the fatigue extract file. Here it is, and then I'm gonna click in properties. We're gonna have some joints listed in here, and we're gonna find some information right here. Okay, and you can right click here and create the reports. there is a dialog here with the input, with the results. You can here generate the response, plot the response spectrum. Choose brace, bottom left, fatigue load, and the spectrum. I'm gonna pick up any of them. The independent variable, we're gonna use frequency. Okay, here's our plot. The results, you can check the damage, maximum damage. We can choose some input information right here. I'm gonna change the thickness from 1 to 1.5, and let's check again the results. So as you can see, it has changed. Also, we can change this one to 2.5 and this one to 1.5 and check again. So it's less than 1 as expected. So that's it. Hope you enjoyed, and thank you for your attention. Bye bye.